for being here too. Did anyone go to Rave last night? A couple dark guys in the crowd, so it's good seeing you. All right, thank you guys for being here. We're going to be talking about how to build with EAS in a simple way. If you're not too familiar with EAS,
What's that? Can you restart for the stream? Sure. Oh, yeah. Thank you.
Same jokes? No? Okay. Good?
Yeah, it is.
Thank you all for being here. I appreciate you being here on the very last day of ETHCC. It's been an awesome week. All the side events, all the speakers here, it's been really awesome. Would love to spend some time talking about Ethereum Attestation Service. Earlier, we did a raise of hands who knew about EAS, and it was nice to see half of it. Last ETHCC, we were pretty new still, and it's been amazing seeing kind of the growth of the protocol and the different teams that we've met who just said, hey, thank you so much for building EAS. Here's how we're using it. And so one thing that we're really adamant about is how do we actually help builders build faster? And so that's the whole spirit of this presentation, is to be a bit more technical. If you're not familiar with EAS, what we're going to go through is a quick intro on why EAS exists, because it really helps people understand like the importance of what it can be used for and really the mission that we're after. We'll talk a little bit about the traction, then we're going to dive straight into the dev tools, and then we actually built an example demo app that we called the Truth Bot. It's an open source app. You can find it in the repo. And we'll go through just like how we thought about some of the decisions in building that app. And we'll try to keep this very fluid with the crowd as well. So if you have questions, feel free to ask them. And we'll make sure that there's plenty of time at the end as well. But if you have something as we're going through it, this is meant to be educational. So happy to pause and answer if you think it's helpful for you and others. So for speaking, I'm Bryce. I lead all like product operations, any of the design stuff. I design it, then Steve implements it, and then if Steve implements it and I need to like tweak something, I might do that, but I really try not to. I just focus on the product side. I'll let Steve do his intro, and then we'll dive in.
Hey guys, I'm Steve Dack, CTO and lead full stack dev of EAS.
So Ethereum Attestation Service is a public good for making attestations on-chain or off-chain. Just by a raise of hands, how many of you are familiar with what attestations are? Cool. Yeah, it's a newer term, and sometimes it can be hard to say, but we're going to really just, it's the most accurate term for what this is. Some people might get it confused with, like, is it a claim? Is it a verification? Is it a proof of something? And it can be all of those things depending on its context. So attestations are really just like the core term that really represents what this is. When Ethereum first started in 2014, Vitalik got his standing ovation, right, and saying, hey, I want to decentralize the world. Let's decentralize land registries and all these things. And here we are 10 years later, and we've made a ton of progress. However, we still haven't been able to achieve some of these other use cases like supply chains, and we have the meme cycle right now and some of these other use cases, but we really haven't solved a lot of like the core use cases that really inspire people about what blockchains can do. And we believe that it's not immediately obvious to go from this idea of a smart contract to actually solving some of these problems. And when you think about like the core thing of what's here is we want to be able to decentralize more than just money and assets with Ethereum. But the who is the hardest part, right? Like who's actually behind, like if you have a land title, right, there's usually some sort of authority that says this parcel of land is a verified piece of land. But it's based on an identity, but identity is like what actually even is identity? It's not the piece of plastic in your wallet, right? An identity card, that doesn't represent who you are. And when we looked around the identity ecosystem, it was really fragmented. You had, handfuls of protocols all solving decentralized identity, but they might be just like a KYC verifier. But that's not what identity is. And so because of this fragmentation, we're thinking, well, what actually is identity? And how could it actually be represented in this decentralized world? Maybe everyone's building a layer too high. So we thought, what was your first identity? So think about it. So like, what was my first identity? At one point in your life, you didn't have an identity, and then you did. There was some moment in time when that happened. And we realized that your first identity is when your mother names you, right? You could say that she attests to your name, or your parents did. And then throughout life, other entities start attesting to different aspects of who you are. Like they could attest to your date, the doctor attested to your date of birth. The government might have attested to your passport, right? Your driver's license. You go to school, the teacher attests to your grades. You finally graduate and you get a job, and people are attesting to your skills as like a good employee or not. And if people trust you, but you're also issuing attestations as well, right? You can attest to friends that you like, people that you trust. But in this decentralized world where everyone's kind of hiding behind an address, it's really hard to know who to trust because a lot of this contextual information can be missing. And so an identity can actually elegantly be represented as this aggregate of attestations about an entity over time. But we also need to be able to trust the things that we interact with, not just who. Especially in this age where everything seems very adversarial. Every link that you click, I'm sure a lot of us are always like very skeptical of, in our industry of clicking random links from people. Content we consume, a lot of it gets received with a lot of mistrust because you just don't know the authority or the entities behind it who are actually making these statements. And it's only going to get worse. I'm sure you've all seen a lot of the deepfakes that have been launched with like Elon Musk promoting things or even Vitalik promoting something when he didn't. But these deepfakes are going to get harder and harder to discern. And we believe that smart digital signatures and cryptography are one of the best ways to actually solve through this. And so this is where attestations come in. So attestations are simply just a digital signature on a piece of structured data. In the way that EAS works, which we'll go into way more detail in this workshop, but you register a schema, which is basically the type of the attestation. So if you're registering for like an event or something, you might have event ID, event name, or something like that. And then you make a digital signature over that, applying some data, and that's the attestation. So you register a schema, and then you attest with it. And there's some other functionality and tools that we'll go into for like resolver contracts that allow you to control who can make attestations, mint an NFT after an attestation is made, whatever smart contract logic you'd like. There's been over 1 million attestations made so far since we deployed. We're across 10 different chains, primarily in the super chain right now, but Arbitrum, Polygon, Linea, basically any L2 that has builders building is where we want to see EAS live. And it's been natively integrated into Optimism. So if you're familiar with the OP stack, they have the concept of the super chain. And a lot of the chains use the OP stack, and then EAS was natively integrated into it, linked by 2 pre-deploy addresses. So anytime a super chain or a new chain gets deployed with the OP stack, it automatically has EAS as a part of it. Coinbase uses it for a new product they have called Coinbase Verifications, where they attest to a verified user or address. Gitcoin Passport uses it kind of like as an Oracle service, if you will, to attest to their off-chain score on-chain. So if you get a Gitcoin Passport score and you want that data to be on-chain, they use EAS to attest to that score on-chain. Devfolio recently used it. Did anyone here participate in the on-chain summer build-a-thon? Nice. So there's a quadratic voting system happening right now where the builders can vote for the projects that they want to see like win an extra prize pool. Underneath the hood, this quadratic vote is actually an attestation where the hacker is attesting their ballot, basically, of who they want to see win the prize pool. But as you can imagine, because this is such a primitive and like it's so abstract that it can be used for so many new use cases. So voting systems, authenticity of information, marketplaces, proof of anything, compliance and verifications, Oracle services. We recently ran a fellowship program where we had 155 different teams apply from over 40 different countries. We didn't have any bounties or prizes. It was just raw passion from these teams trying to solve a unique problem. And the coolest part about it was like the diversity in use cases. Because of how simple EAS can be used, it can be used to really build entire products off of it or just use as a point in the product as well. So we're going to start diving into EAS, but there's a lot of tooling that's been built around EAS beyond the core contract. So there's a lot of helper contracts. We have the Attestation Explorer we'll dive into. There's a GraphQL API that's accessible. It's free. there's an indexer, and then there's hundreds of open source projects that have implemented it that you can kind of dive into as well. We're going to go through one of them. And really, we want to be able to help you guys answer a lot of the common questions that we get when we're helping teams. What schema should I use? How can I prevent someone from making an attestation with this schema? Or like, what's the purpose of a resolver contract? Should I make my attestations on-chain or off-chain? What if I don't want to actually pay for the gas or have the user pay for the gas for the attestation? How could I do that? And then some other features. So I'm gonna pass this over to Steve. We're gonna talk about this like very simple app we just built before this conference called TruthBot. And essentially, you type in a statement, and then this bot attests, so the server attests whether or not the statement is true or not. So let's open it up, and I'll pass it over to Steve.
Before you do that, hey guys, TruthBot is just this demo app that we put together a few days ago to show off just like a simple implementation of EAS. TruthBot uses Scaffold ETH to make it super easy to show you guys that you can build using the tools that you already have. The EAS SDK uses a simple schema to attest with, uses off-chain attestations, which are free to make and still sign with your wallet. It uses reference attestations. It uses the GPT-4o via the OpenAI API and the GraphQL API. And I'll just give you a quick demo of what this app looks like. All right, so
this is also in our repo too.
yeah, so this app is available in the EAS GitHub org, so you can find the repo there. So for example, here you put in any kind of statement. So I'm just gonna put in something like Vitalik.
This is a French keyboard.
Vitalik. Oh crap. All right, Vitalik Buterin is 7 feet tall. Okay, so I put a statement. It's not true, obviously. And so if I send it here, the LLM responds false. There's no credible evidence or reliable source that supports the claim that Vitalik Buterin is 7 feet tall. And you have an off-chain attestation that's being made. So this off-chain attestation, by default, is actually private. And I'm going to click into it, and you can see there's an attestation from some address, and then it follows the schema, where you can see this is the input, this is the model that's being used, this is the validity, and like an additional critique. And then also it here lists recent attestations that have been made. And you have the option to like publish a result, to make the off-chain attestation public, and you have the ability to also upvote and downvote. So users can themselves be like, oh, you know what? I actually agree with this attestation, and then now this attestation gets additional kind of like trust or distrust. So we'll go into how it kind of works. So. So the first thing, obviously, is that you have to pick a schema to attest with, and in this case, we knew we needed to attest to the statement that the user sends in. We wanted to have the validity of the statement as like a simple true or false, but also can be invalid or unsure, and also the model being used and the critique. And so, in general, if you are looking for a schema, you might want to find something that already exists. But in many cases, right now, you might not find the schema for your specific use case, so you would create one. And in this case, so just before we go forward, this is the EAS Explorer on Sepolia, but we are on a ton of different chains, pretty much every L2 that has developers on. And EAS Explorer is like the EtherScan for attestations and schemas. You can see all the schemas that have been deployed. You can actually deploy them directly on here. You can make attestations on here and view all the attestations that exist. So that's what you were looking at before when we were viewing the attestation. You can post off-chain and on-chain attestations to the Explorer.
you'll see that in the schema registry, there's a lot of different use cases. EAS doesn't presuppose what schema is best for each use case. So you can define the right types, like different types. You can come up with whatever data structure you want. And you can kind of get an idea. Here's someone who's attesting to something is true or false is trustable, and then a name of something. And there's some attestations on it. So I'll just click on this one as an example. But you can kind of see what people are registering. What this does is it provides structure, right? So other people can make attestations in a similar way. And so this schema, there's a creator, but it's actually not a part of the struct. You can see the type of the attestation, and then the attestation's made with that schema type down below. And so you can dive into it and see that for this specific attestation, is trustable true, and then some name, and then there's a reference attestation there, but you can kind of see what's being made or not. Go ahead, Steve.
All right. So in this case, our schema simply has 4 fields. They're all strings, so just made it really simple. Technically, the validity, since it was in the model, since usually it's a small string, it probably could have fit into a bytes 32. But since the attestations are all off-chain, and they're free, we figured, let's just make it strings for everything. So, this is the schema. You can see like the raw schema is simply just like an ABI kind of function signature, not a signature, but well, I guess the signature. Let's go next. And so when you go on the schema page in the Explorer, not only can you see the schema, we actually made it super easy. We give you like an actual code snippet that actually allows you to make attestations with that exact schema. So here we can see an example of how you can make an on-chain attestation using EAS. So yeah, for example, for this one, you can see it's the example for this particular schema. So it makes it super easy to just get started. So one of the important things when you're designing your tool or your app, you might be thinking like, should I do on-chain attestations or should I do off-chain attestations? The real question you need to ask yourself is, do my attestations need to be read by smart contract? If so, then it probably makes sense for them to be on-chain from the get-go. If they're meant to be verified by humans and machine and not necessarily read by smart contract, it might make sense to do an off-chain attestation. And the differences really are, if you have an on-chain attestation, it's stored on-chain, it's in the storage of the EAS contract. If you make it off-chain, the attestation can literally live anywhere. When you make an off-chain attestation with this app, it actually, the second you get it, it's just literally just in the browser, in the just like the temporary memory of the browser. If you don't publish it and you don't copy it, you don't save it, you don't share it with somebody, it's basically like it never existed. On-chain attestations can be verified easily by smart contract and read by smart contract. Off-chain attestations can also be read by smart contract. It's just a little bit more expensive. Timestamping, on-chain attestations are obviously timestamped with the block time of the transaction of the attestation. Off-chain attestations aren't timestamped by default, but we do offer the ability to timestamp off-chain attestations as well as revoke off-chain attestations. So you can still have basically the power of on-chain attestations with off-chain attestations in many cases. As far as privacy, on-chain attestations are public. Off-chain attestations are private by default, but can be published and shared with whoever they need to be. And of course, off-chain attestations are free, so sometimes they can be useful, especially for companies that, and situations where the user may not have Ethereum in their wallet and they still want to be able to make attestations. So it can really help bring, bridge the Web 2 gap by, bringing people who are don't have ETH, but still could download the wallet software and interact with this technology. So, all right, we're going to talk about how to make an off-chain attestation with the SDK, because this is what we used, and I'll just briefly go through here. go through the, yeah. Our demo is not as smooth because it's not our machine, but here we go. All right, so this is actually the code from this, the truth bot. And so you can see this first line, we just set the address of the EAS contract, and there's a different address depending on what chain it's on, unless it's on Optimism. So on Optimism on Base, on any OP stack chain, the EAS contract address is like 0x 0x420 and like all zeros and ends in like 21. So it's a special address on all superchain chains, and we have a list in the GitHub repo. You can find all the addresses, and then here we specify the schema ID. This is the schema ID, and we can actually look it up. What is the schema ID? Oh, wait, are we in the wrong chain? There it is. Okay. Whoops. Okay, so this is the schema that we're attesting with this schema. Here we just set the provider, and in this case, so the attestation in this case, this is the route that verifies the truth when it gets sent in. So the server is actually attesting. So in this case, we have like a hard-coded key, or in the environmental variables. So we create a signer. We instantiate the EAS object, which takes the contract address in the signer. Then we have the schema encoder class, which deals with how do you encode all of the schema data into like a bytes blob. And so this deals with that. So you initiate the schema encoder, you pass it the actual raw schema, which you can get from here. And you call encode data, and you pass an array of all the objects matching the schema. Because we're doing off-chain, we call this to get the off-chain class object. And then we call sign off-chain. We pass the data, the schema ID. In this case, there is no recipient. Sometimes you're making an attestation, and you're not necessarily making it to somebody. Like if I was to say, like, I met Bryce in real life, maybe I would attest to his address, but maybe I'm saying, hello world. In this case, there is no recipient, so here we use the 0 address. Off-chain attestation, since they're not time-stamped on-chain, you have to give it a timestamp. So in this case, we're just giving it the current Unix timestamp. Attestations can expire, and in this case, with a 0 expiration time, it does not expire. And attestations can reference other attestations, so you can attest to another attestation, and this is how the upvoting and downvoting works. Sure.
Yeah, for the expiration time, it's a really powerful utility, because imagine if you want to give someone grant access for a period of time, you can make an attestation saying I attest this address or this entity or this thing has access, and then after 30 days it could expire, right? And then you could reattest. Or if you need some ongoing verification, maybe it's on access, but you just want them to, maybe it's like they have a role in a DAO or something, and you attest that they are a verified member for this period of time. And then they have to re-verify again 30 days later or a day later, whatever it is. But the expiration can be really powerful.
Additionally, attestations can be revocable as well. So, imagine receiving some sort of credential. Maybe like it's a credential that you work at a particular company, and then when you leave, that attestation would be revoked. And because it's revoked, it doesn't mean it's deleted, it doesn't disappear. You still have this proof that you had it from a particular time to some other time, and that could be used as a credential somewhere else. Okay. So off-chain attestations, we said this before, they're private by default. One of the cool things about off-chain attestations on EAS is they can be passed around in a bunch of different ways. So this QR code actually has the entire encoded off-chain attestation with the signature and everything. And what's cool about this is, say you make an attestation and it's on your phone and you want to pass it to your friend, they can just scan the QR code and load it onto their phone. And it's fully verifiable because the entire data is encoded and compressed into this QR code. Additionally, you can also share these attestations as a URL. Are you going to click on it? Yeah, I'm going to click on it. All right, do it. Yeah. So
You could have scanned that, and then so you can see that it's encoded in the URI fragment. You can just
yeah, so in this case, the attestation is encoded in the URI fragment, and what's great about this is the attestation doesn't actually get sent to the server, so EAS EAS has no idea about this attestation, that it even exists. It's completely private. The only way you can download it as a file, you can share the QR code, you can share the URL, and this trustlessly transfers the attestation, and the other entity can verify that 100% this came from whoever signed it. Because inside this attestation is actually the full EIP 712 signed data, and the signature is everything that you need to verify that this attestation came from the user that signed. Is that the next one? Oh, yeah. All right. So once an attestation is either on chain, or if you take an off chain attestation and publish it, how do you discover them? So we have a few different ways. Off chain, we index all of our attestations on the on chain ones and off chain ones, and we provide public GraphQL APIs at every single one of our all the chains that we support. So if you go on that GraphQL link, you actually get access to a playground, and you can actually just create test queries on there and test out all sorts of, and you can see the entire structure of what we have. So you're able to easily find any kind of attestations that you want by schema, by recipient. You can pull information like transaction ID and all the schema information. Everything that you see on the Explorer is available through the GraphQL, as well as the ENS name resolutions for the resolved ENS names. So you can quickly, for example, we can say we want all attestations, we want the data, the attester, the ID, the recipient, whatever. What happened here? All right, and then we want, where maybe where the schema ID. Okay, I think I have it saved here. Where's the quote? This quote?
Yeah.
Is that a quote? No.
It's a different language keyboard.
I don't know what's happening. You copy that? Genius. All right, now we got to get the. Okay. Now, hopefully, if I run this, whoa. All right. Oh, variable invalid. What's the problem here? No, I don't think that's it. Something here. I'm not sure what the issue is here. I think it might have to do with
Type string to be an object.
Oh, okay. I know why. All right. Crap. Where do I find the bracket? This is really hard with this keyboard. Oh, there it is. Oh my God. All right, whatever. Anyway, it's super simple. You can write GraphQL queries on here when you have a regular keyboard that you understand. And I promise you it works. We had all these examples pre-listed before on our previous version, but we had an issue. So if you want to upvote and downvote attestations, you can use the upvote and downvote buttons. It's not going to work for us here because we do not have a what? Okay.
Yeah, so we're gonna go back to the TruthBot app, and then one of the powers with EAS is the reference attestation, which allows you to reference the previous UID and then make an attestation referencing that. So you can start to build them like Lego blocks and add more context. So in this example for this TruthBot app, we have Vitalik Buterin is 7 feet tall and it's false, right? And let's say, just like in a social media app, if someone makes a comment, that's just an attestation, right? They're posting something, and if someone likes it, they're referencing that post saying that they like it. So similar to that, with an attestation, you can upvote, downvote, you could add more context, right? So I'm going to make one on my other computer, just signing the reference attestation, then Steve can show what that looks like now on the attestation once it's signed.
Yeah, so Bryce just signed and submitted his attestation. So I'm going to go here, and you can see now on this attestation where we say Vitalik Buterin 7 feet tall, you can see that there's one attestation referencing this one. And if you scroll down to the bottom, you'll see that there is an attestation here from this address attesting, and we can click into it, and we can see it's an upvote type attestation, and it's attesting to this reference attestation. And if we click here, you go back to that attestation. So this is a good way to create like kind of composability, where like imagine you have some fact and like a bunch of trusted entities attest true or false, and this can kind of help back up the initial claim, and this can be used for a ton of different things. One example that we had before is we made this demo app called Met in Real Life, metirl.org. I can attest that I met Bryce, and then Bryce attests to that attestation that it's true. What was the question?
Question, the UID of the entity making the attestation or referencing it, what do you recommend or best practices for identifying that UID and associating it with a person or an entity or
Yep.
something?
Yeah, so one of the best ways that people do this is using ENS.
Yep.
So if you go over to like Coinbase, Coinbase, like Bryce said earlier, uses EAS pretty heavily. So here's the base chain, and you can see a few seconds ago verifications that Coinbase.eth attested to some address that they have a verified account. Yep. Want to go next? We went over this. So there's other functionality that you can leverage with EAS. So we have resolver contracts. Resolver contracts are useful when you want to control who or how attestations get made. So for example, perhaps you have some like allow list, and you only want users that are within this list to be able to make attestations on that schema. And let me actually just quickly go over the schema registration. So if you go to the schemas list and you go to create a schema, you'll see it's very easy. Actually, we make it really easy to make. You can just pick the data types that you want, and you can just, wow, where's the M? Okay. And you can set a resolver address here. And so a resolver is a smart contract that optionally you can add to a schema only when you register it. And what happens is anytime an attestation is made to a schema with that resolver, the attestation data will be fed to that resolver, and the resolver has an onattest method. And that if the method fails, it will reject the attestation. So, or if it returns false, so you can do whatever you want. You can actually have any kind of smart contract logic there. So if the attestation is successful, you can have like an NFT get minted, or you can say like only people can only attest once every hour or something like that. You can build in this kind of logic. It allows you to kind of extend EAS into ways that you wouldn't be able to just without that. So delegated attestations is another one. So say I want to make some company wants to let people make attestations for free. So for example, say Bryce doesn't have any ETH, or doesn't want to spend any ETH, but he wants to make an attestation. He can make a delegated attestation, still signed by him, and then I can pay the gas for him, or someone else can pay the gas, and it'll still show up as if it came from Bryce. So that's super useful. Whether you want to subsidize users' attestations, or actually the opposite, you want users to pay for attestations that come from your service. You can do that with delegated attestations. This is something that Gitcoin Passport does. You can timestamp off-chain attestations on-chain. So we have tools for, so because the UID of any attestation is also a hash of the entire attestation, timestamping the UID actually gives proof that that attestation existed at a particular time. So you can use the methods that we have, and it's built into the SDK for timestamping off-chain attestations as well as revoking off-chain attestations. We have a cool kind of tool that we built for private. It's called private data attestation. It allows you to create like selectively disclosed attestations. So you can attest to a bunch of data, and then you can reveal to somebody else, like, you know, 3 pieces of data out of the 20, and they can never, they'll never be able to figure out what the rest of the data is, and it's fully verifiable. So say, for example, the government attests to a bunch of information, maybe your name, your address, your social security number, you know, your phone number, and, you know, if you're over 21, and maybe like some other entity, you only need to prove your name and that you're over 21, you can just selectively disclose those pieces of data. And this works without ZK, so it actually works in the browser, works very easily from your phone and any app. We have tools for being able to batch, multi-attest, and revoke attestations. And there's more, but these are the basic ones. You can find more looking at our docs. And that's it. Any questions?
Yeah, go ahead.
Regarding the word attestation, that is used with the same meaning in EAS, the new digital identity regulation in Europe. Are you planning to prepare to adopt the requirements of the European Union in terms of privacy, unlinkability, and so on?
Yeah, so EAS is a primitive for making attestations about anything. So it could be related to identity, but it could also be used to attest to like authenticity of data, like a hash of a document or whatever it is. So it's really up to the users that are building applications with the primitive to follow whatever like compliance laws there are, whether it's like privacy or whatever it might be, to make sure that they're following it. But EAS, all that it's providing is the digital signature of whatever the piece of data is from the government. And so in this example, let's say the European Union made a digital signature about a piece of like private user data. They could still use, if they adopted Ethereum technology with a wallet, they could make a signature about that user and keep that data, but still have that attestation be able to be verified later. You can also apply ZK on top of EAS as well. So you could have an attestation and then create, you know, a proof from that attestation data as well. But as a primitive, it's just meant to make the digital signature on the data.
And just to like understand, an attestation is simply an entity saying anything about anything, right? They can say something about something. So this is, you know, EAS, we're not the ones attesting. This is just a protocol, kind of like email. You know, anyone can send an email. Anyone can send probably an illegal email.
Yeah, but obviously not talking about the attestation themselves, but the tools you may provide to help this, because European Union is thinking for using, for example, BBS Plus, signature and attestation protocol, or key derivation and unlinkability requirements, and that could be part of your protocol, because if you are not using the same cryptography, the interoperability with the user wallet will be impossible. So that's why my question.
We're not using any kind of mechanism that's unique here. We're just using EIP 712 like type signatures and you know, interacting with smart contracts and storing, you know, attestation data. So I'm not sure it's super relevant. I think it's more relevant for the entities that are using it. We try to make tools so that, you know, users can maintain privacy and build whichever way they want. We have recommendations for how you attest, but, you know, it's not a rule. Yep.
Yeah. Do you have examples of apps that use referenced attestations?
Yeah, and this one actually was one. So those attestations of upvotes and downvotes on the statements, or on the result of the LLM from the statement. Oh, here's a better example. So we created also this demo called Speaketh, and it's like a Twitter, but with every single tweet is an attestation. Every like is an attestation liking the tweet. Every every comment is an attestation. So in this case, there was some, wait, go back real quick. So here, Bryce found a post where this guy, Gavin.eth, writes, "What is EAS?" And then there's 2 comments. And so if you go to that attestation, you can see it's an attestation of type post, where the user says, "What is EAS?" And there are 2 attestations referencing this one, and they're both posts, so they're just replies.
But so it's not something you use to compose 2 schema together?
No, it's not for composing schemas. It's for composing attestations together.
Which could link 2 schemas together indirectly. Yeah.
You could attest to a schema as well, but reference attestations are specifically for referencing other attestations. Yep.
Will the Explorer repo ever be open sourced?
It's something that we're thinking about. The reason we haven't yet is because we don't want to have like a bunch of copycats that are like making it look like EAS is on another chain and doing something malicious, perhaps. But there are other platforms that have actually kind of copied and built like alternative versions. And we do open source our indexer, so it's super easy to get all the same exact data from the Explorer. It's just like our exact brand and design. We don't kind of open source, but all the useful code we're always happy to share, and we usually do and implement all that functionality into the SDK.
And let's be honest, like even looking at this on-chain attestation data, this isn't going to be like helpful for anyone that's not technical, right? Even block explorers in general are pretty scary. And so what we've seen as a trend are people building different visualizations of the attestation data, because not every attestation is going to be relevant to everyone. Right? So if you have an attestation or you built a product for like land registries or something, you only want to query and show and display attestations that are related to that, but that data in the way that you display it's going to look way different. So we've seen people start to like go down that path, creating more like front end specific to attestations that are relevant to their use case only, which is the right way to go.
Yeah, I'm asking because our clients are like semi-technical and they work with permission chains. So it would be like very cool if we could deploy EAS and then also show the Explorer as a final step. So yeah, I also asked on your forum.
So, oh, nice. Okay, cool.
Yeah, we need to be a little bit better on that. The Telegram chat is probably...
It's probably the fastest way to get a response, yeah.
Any other questions?
Yes. Is there a way to have attestation that can be revoked but by more than one user?
Can be created by more than one user?
No,
Revoked.
Revoked by more than one user. Well, if the attestation is made from a multi-sig, then yeah. You know, you can have a multi-sig where multiple users are in chart, have like multi-sig. Either they could be like one of 4 or 2 of 3, and you can attest or you can revoke as a group from a single entity.
I'm thinking more of a use case where there's one admin, for example, that attests identity, and then it's either admin or multiple admins that can revoke it, or it's the attested address itself can just burn it. Is there?
I mean, you can build a smart contract to do that. Yeah, you can build a smart contract to give you that same permissions and be able to revoke from whatever logic you want.
Yeah, maybe the problem with smart contracts that I have is that then the UI is not applicable anymore, right? You cannot like use your UI to then...
The EAS UI? Yeah, you're correct. You wouldn't use the EAS UI to attest, but usually people don't. Usually people build front ends on top of it to make it easy. Some people attest directly on the front end, but for simple attestations. But in general, it makes sense to make a unique UI experience for this.
Maybe another quick question is about different versions of the EAS. I've seen that mainnet have like a old version, and then there's newer. What's the difference and why it's not?
The differences are usually very tiny. I think in the difference between mainnet 1 and the new one is a different type of delegated attestation mechanism that uses a deadline where the previous one didn't have like a deadline. So you can set when you set a delegated attestation, you have to handle nonce. In this new version, you just set a deadline. Yep, and 1271 support. But we're gonna actually create eventually, if we do an upgrade, we're going to create like a V2, not yet, but if we do create a V2, it'll just inherit all of the attestations from V1, and it'll just have like slightly changed functionality. But we don't plan on changing the protocol much at all. It's purposely very simple and not meant to really change. Yep.
Hey, thanks for the presentation. Maybe I have one live question. When you create, someone create a attestation, like how people can trust the person or
Yep.
anyone who created attestation?
Yeah, so the value of the attestation is based on who attests, right? So if I attest that you passed KYC, it's probably not valuable. But if Coinbase does, it probably has some value, right? If Coinbase attests to me that I'm someone important, and then I attest to you, that might also have some value, right? Because it's kind of like this transitive trust situation. And we're actually working on an algorithm right now that we're going to release soon that allows you to kind of calculate relative trust scores based on attestations that you've made and other people that you've attested to have made, and down the line, like could be many hops away.
Okay, so it's, you mean it's like based on which network they are using, so you guess that like, okay, this account, this wallet address, we don't know who it is, but it's something like we can trust or not.
Well, you would look at that address and you would see what attestations do they have. Do they have an attestation from somebody that we know in some way? And then, like, for example, if someone goes out and gets a Coinbase verification attestation, you can at least be like, well, they went through KYC, so that's, and maybe they have one that says that they live in Germany, then you can probably say that most likely they live in Germany. And it's way stronger signal than like using their IP address, for example, because that can be like easily, gamed.
Okay.
Yep.
Yeah, and so as Steve was saying, like the value of the attestation, who signs it, and so, but it's up to the interpreter and like the use case whether or not you trust them. Because if you think about like just making a decision in the real world for like choosing what restaurant to go to, right? You could ask a local or like a friend here in Brussels and be like, "Yo, where can I get like the best waffles?" Right? And they'll be like, "Oh, you should totally go try this place." That might be good enough for you, right? Because their attestation and their relevance and their connection to you is strong. Or you might be like, "Hey, I don't know someone that might know that, so maybe I'll trust the wisdom of the crowd and look at 5,000 reviews, and that's what I want." Right? But it's really up to you to decide what attestations or comments from who matter to you to actually make that decision. Because even with Coinbase, like maybe you don't like Coinbase or for whatever reason, right? Like they might not be a valuable attester to you. And that's your choice, and that's the whole point. But what EAS provides is just the verification that this wallet address signed a piece of data, usually at this time if it's on chain, right? And it's up to you to interpret like how relevant or important it is.
But like, for example, let's say I'm in ETHCC, right? So
Yeah.
if there's a ETHCC official like KYB passed something address says that I attended here, then it's going to be more trustable, right?
Yeah.
But if like, for example, like Vitalik says that like he was here or not, like even if he's like very named person, he actually doesn't know the.
Most people will probably believe him.
Yeah, it's up to like if you at the end of the day, it's like what wallet address is making this verified signature of this piece of data, and do I trust that entity, and is the data relevant to me or not? So like if ECC says that you attended and people trust that this ECC's address said that, then it could be useful. But it could also be maybe Vitalik said that he met you in person, and that's valuable enough to prove that you were present or not at ECC.
If you know that Vitalik was there.
Yeah.
Yes. Okay. Thanks.
Any more questions? No? Come find us so we're very active in the Telegram group. We help devs all the time. We love like learning how to make the DevX easier. We've been investing a lot of time into like figuring out how to add more tools and things. So if you have ideas on what would like help you build better, then let us know. And we're eager to help you guys and figure out how to implement EAS in the easiest and best way possible. So